Work and energy. What is energy? Energy is the ability to do work. What is the unit for energy? Joules. Joules. Joules, joules, joules. What is the unit for work? Also joules. Joules. Joules, joules, joules. When work is done, energy is transformed or transferred from one system to another. Examples of work are the student lifting a backpack, and another student lifting some weights. So when work is done, a force is exerted upon an object that causes a displacement. So work is when a force causes a displacement. What isn't work? What isn't work? What isn't work is when no displacement is occurring. If you look down here, it says a horse pulls a car stuck in snow. After an hour, the horse is exhausted but can't get the car out. How much work was done? The horse pulled and pulled and pulled, so it sounds like it's doing work. It pulled so hard that it was exhausted, but since the car didn't move, according to our science definition of work, no work was done. Only when a force causes a displacement is work done. The unit for work again is joules, and another example of work is lifting an apple from your waist to the top of your head, and that's about a joule of work. A joule of work is moving 1 kilogram, 1 meter. So number 7, here's our formula for work. Work equals force times displacement. Work equals force times displacement. And we've got an example problem there, a force of 500 newtons. And this is our picture here. A force of 500 newtons is applied to an object with 100 kilograms of mass to move it 6 meters. How much work was done? So work equals force, 500 times distance, which was 6 meters. So 500 times 6 meters would be 3,000 joules of work. 3,000 joules of work. So we're down to number 7 on your paper. Another example problem. A car has run out of gas. Fortunately, there is a gas station nearby. You must exert a force. So our force is 715 newtons on a car in order to move it. By the time you reach the station, you have traveled. Our distance is 38 meters. How much work was done? Work, we don't know. Work equals force times distance, which equals 715 times 38. 715 times 38 is 27170 joules. 27170 joules. Potential energy is stored energy of position possessed by an object. Gravitational potential energy is the potential energy something has due to gravity. The potential energy something has due to gravity. The formula for calculating gravitational potential energy is on the screen here several times. It's mass times gravity times height. It's down here. Potential energy due to gravity is m times g times h. And remember that gravity, acceleration due to gravity, this is a constant. This is a known. We're going to know this all the time. This is not going to be given to you in a problem usually. Acceleration due to gravity is 10 meters per second squared. So mass of the objects times acceleration due to gravity times the height. That's how we calculate gravitational potential energy. And here it is again. And it asks you for the formula in words and symbols, and then it's got an example problem. A person lifts a 200 kilogram box, so that's our mass. Mass equals 200 kilograms from the floor to a shelf 2 meters above the floor. So our distance is 2 meters, and we know acceleration due to gravity is 10 meters per second squared. So our gravitational potential energy is mass. So our potential energy is mass times gravity times height, which is 200 times 10 times 2. 4,000 joules. Kinetic energy is energy that is in motion. Potential energy was stored energy not in motion. It has the potential to move or do work. Kinetic energy is the energy an object has due to its motion or because of its motion. The formula for kinetic energy in words is 1/2 mass times velocity. One half mass times velocity in words. There's the formula 1/2 mv squared. And then we've got an example problem for kinetic energy. A 725 kilogram automobile, so this is mass equals 725 kilograms, is traveling at a speed of, or velocity, a velocity of 28.9 meters per second north. When we get a velocity, calculate its potential energy. 1/2 mv squared. Remember to do that squared. So we've got 1/2 725 times 28.9 squared. So do the squared first so you don't forget. 28.9 times 28.9, enter, was 835.21. And then I'm going to multiply that by 725. And now I've multiplied those two together, and on my calculator, I've got 605527.25, and then I'm going to divide that by 2, or 1/2, to get my final answer, 302,763 joules. Kinetic energy equals a lot of joules. So conservation of energy changes forms, but the total amount of energy stays the same. And the point here is however much energy you have at the top of the roller coaster, your maximum potential energy, all the energy right now is 100% potential, 0 kinetic. Halfway down, you're 50% down this hill, you're moving now, so half of your energy has been transformed into kinetic, and you still have some potential because you still have a ways to fall, so you've got 50 potential. At the bottom now, you have no potential energy anymore. You can't fall any further. All of your energy is due to motion, and as you roll back up, it's transformed back into some potential based on your height and a lot of kinetic because you're still moving. So sketch that roller coaster there in number 19, and then bring those papers to me to be checked.